This video is about factoring and solving a quadratic equation with an a value of 1 and factoring and solving a quadratic equation with an a value that is other than 1. So today we're going to factor some sneaky box problems. These still are box problems, but they look a little different because there's no x term. But we could get an x term by rewriting it so as x squared plus 0x minus 16. So we're still doing the same thing. We're trying to figure out what multiplies to negative 16 and adds to 0. So in this case, it has to be the same number. So another way to think about these problems is that these are going to be perfect squares that we can factor. So in number 1, we have x squared minus 36. So we need two numbers that multiply to negative 36 and add to 0 because there is no x term. So two numbers that multiply to negative 36 and add to 0 are negative 6 and 6. So another way we could have thought about this is that the square root of 36 is 6, and we get one of each sign. So I'm going to break x squared into x and x, and then I have x plus 6 and x minus 6. Now, number 2. This is a little different because there's a plus sign in the middle. So I need to see what multiplies to 4 and adds to 0. The problem is nothing multiplies to a positive that's going to add to 0. So anytime it's a plus sign in the middle, this is going to be a not factorable. Number 3, x squared minus 25. So we need two numbers that multiply to negative 25 and add to 0. In this case, that's 5 and negative 5, which again makes sense because the square root of 25 is 5. So we have x minus 5 and x plus 5. Number 4 and 5, now there's an equal sign, so we're going to factor and solve. So if we have x squared minus 100, we need two numbers that multiply to negative 100 and add to 0. So those numbers are going to be 10 and negative 10. So we have x plus 10 times x minus 10 equals 0. Now, because it's equal to 0, remember, we're going to have to use the zero product property. So we're going to set each of these equal to 0. X plus 10 equals 0. And x minus 10 equals 0. So in the first one, when I subtract 10 from both sides, I get x is negative 10. The second one, I add 10 to both sides, I get x is positive 10. In number 5, before I can factor, I need to move the 121 over. So I'm going to subtract 121 from both sides. So x squared minus 121 equals 0. So I need two numbers that multiply a negative 121 and add to 0. So I can think about the square root of 121 as 11. So I'm going to have 11 and negative 11. So x plus 11 times x minus 11 equals 0. Again, we have to use zero product property. So when I split this up, x plus 11 equals 0. Subtract 11 from both sides, so x is negative 11. And in the second equation, I can add 11 to both sides, so x is positive 11. Now let's try some different problems where we don't have an x squared term, but we can factor out a GCF. So to get an x squared term in the first one, I know that both numbers are divisible by 4. So I'm going to factor out 4 as my GCF, which leaves me with x squared minus 9. Now, the x squared minus 9, I can factor what multiplies to negative 9 adds to 0. That's going to be 3 and negative 3, because the square root of 9 is 3. So I have 4, because that's my GCF, times x minus 3 times x plus 3. Number 7, both numbers are divisible by 5. So I'm going to factor out a 5, and I'm left with x squared minus 25. We already did this earlier. Two numbers that multiply to negative 25 and add to 0 are 5 and negative 5. So I have 5 times x plus 5 times x minus 5. Number 8 and 9, again, have equal signs, so we're going to factor and solve in this case. So in number 8, both numbers are divisible by 6. So my GCF is going to be 6, which leaves me with x squared minus 100 equals 0. So I need two numbers that multiply to negative 100 and add to 0. So two numbers that multiply to negative 100 and add to 0 are 10 and negative 10. So I have 6 times x plus 10 times x minus 10 equals 0. Now, because 6 does not have an x, we're going to ignore it when we do zero product properties. So we're just going to say x plus 10 equals 0, and we can subtract 10 from both sides, and we get x equals negative 10. In the other equation, we can add 10 to both sides, so x is positive 10. Number 9, first thing I have to do is I need to subtract 245 from both sides. And I get 5x squared minus 245 equals 0. Both numbers are divisible by 5, so 5 is my GCF, and I'm left with x squared minus 49 equals 0. So I need two numbers that multiply to negative 49 and add to 0. Well, if I get stuck, remember the square root of 49 is 7, so I have 7 and negative 7. So 5 times x plus 7 times x minus 7 equals 0. When I go to solve for x, I only have two terms with variables. So x plus 7 equals 0, x is negative 7. And x minus 7 equals 0, so x is positive 7. Now, in the last one, tricky ones that we're going to look at, we cannot factor out a GCF. The good thing about these is all of the numbers are perfect squares, so we can just take the square root of them to break our problems up. So the square root of 4 is 2. So instead of just x and x, we're now going to have 2x and 2x. Remember, we need a plus and a minus sign. The square root of 25 is 5, so each parenthesis gets a 5. In number 11, the square root of 100, x squared, well, the square root of 100 is 10, and x squared breaks into x and x. So we have 10x and 10x. We're going to put one of each sign, and the square root of 49 is 7. In number 12, it doesn't matter that the variable is not first because they're both perfect squares. So the square root of 81 is 9, so we're going to have 9 and 9 equals 0, and we're going to have our plus and minus sign. The square root of 4y squared, well, the square root of 4 is 2, and the square root of y squared is y and y. So we have 2y and 2y. Now, because this one's set equal to 0, we need to use the zero product property, which involves a couple more steps this time. So when we set them equal to 0, the first step we need to do is subtract 9. And we get 2y equals negative 9, divide by 2, and we get negative 9 halves. In the second problem, we subtract 9 again and divide by negative 2. So y this time is positive 9 over 2.